Hello students, welcome to Methodology classes 9396 where math meets logic. I hope you are enjoying your summer holidays along with some studies. In the previous class, we started chapter 2 polynomials of class 10th. We discussed zeros of a polynomial and its geometrical significance. After that, we discussed questions from exercise 2.1. In this class, we are going to discuss a very important concept. This is helpful in many competitive exams also. So we are going to discuss relationship between zeros of a polynomial and its coefficients for a quadratic equation and a cubic equation. CBSE has removed the cubic equation part from its rationalized syllabus. So if you are just focused on the board examinations, you can leave the cubic equation part. So let us try to find out what is the relationship between zeros of a polynomial and its coefficients. So for that, first of all, let's take the simplest polynomial, that is the linear polynomial. So if I take an example, the general form y is equal to ax plus b, and if we try to find out its 0, so what we do? We equate the right hand side of that polynomial to 0, y is equal to ax plus b is equal to 0. Now let us shift the constant term b to the right hand side. So we will get ax is equal to negative b, and if we divide by a on both the sides, so we get x is equal to negative b by a. So this is the relationship between the 0 of a linear polynomial and its coefficients. So we can write 0 of a linear polynomial ax plus b is equal to negative times b is constant term, so negative time the constant term divided by a is the coefficient of x. So the 0 of a linear polynomial is given by negative times the constant term divided by the coefficient of x. For example, if we have y is equal to, suppose, 2x plus 5, so we can write its 0 is negative times the constant, that is 5, divided by the coefficient of x, that is 2. So this is the relationship between the coefficients and the 0 of a linear polynomial. Now let us try to find out, is there any relationship between the zeros of a quadratic polynomial and their coefficients or not. So for that, let us take an example. Y is equal to 2x square plus 6x minus 8. To find out its 0, we will equate the right hand side, that is 2x square plus 6x minus 8 is equal to 0. So we can factorize it by splitting the middle term. So here the coefficient of x square is 2 and the constant term is negative 8. So their product is negative 16 and the coefficient of x is 6. So we have to find out two terms whose sum is 6 but their product is negative 16. So we can easily find out 8 and negative 2. Their sum will be 6. 8 plus minus 2 is equal to 6, and their product 8 times negative 2 is negative 16. So we got two terms whose sum is 6 and product is negative 16. Now we can factorize it. So we can write 2x square plus, we can write 6x as 8x minus 2x minus 8 is equal to 0. Now in these two terms we can see 2x is common, so remaining will be x plus 4, and in these two terms negative 2 is common, so we can write x plus 4 is equal to 0. Now in these two terms again x plus 4 is common, so we can write x plus 4 times, and whatever is left, that is 2x minus 2 is equal to 0. Now x plus 4 and 2x minus 2, depending on the value of x, are two real numbers and their product is 0. Now product of two real numbers will be 0 only if at least one of them is 0. So we can say either x plus 4 is equal to 0 or 2x minus 2 is equal to 0. Now x plus 4 is equal to 0, it means x should be negative 4, or 2x minus 2 is equal to 0, so I can write 2x is equal to 2, and dividing by 2 on both the sides we get x is equal to 1. So the two zeros are x is equal to negative 4 or x is equal to 1. Now our equation was y is equal to 2x square plus 6x minus 8, and if we compare it, so let me write y is equal to 2x square plus 6x minus 8, and if we compare it with y is equal to ax square plus bx plus c, so we get a is equal to 2, b is equal to 6 and c is equal to negative 8. Now if we try to find out the sum of the zeros, so sum of zeros is equal to negative 4 plus 1, that is negative 3, and if we see, we can write this as negative 6 over 2, that is negative 6 is b over 2 is a. So negative b over a is the sum of the zeros. Similarly, product of the zeros, that is negative 4 times 1 is negative 4, and that can be written as negative 8 by 2, and negative 8 is c and 2 is a. So we can see that sum of the zeros of a quadratic polynomial is given by negative times b over a, and we can write negative b is the coefficient of x over a is the coefficient of x square. Similarly, c is constant term over a is coefficient of x square. So we can see this is the relationship between the coefficient of a quadratic polynomial and their zeros. So the sum of the zeros is given by negative times coefficient of x over coefficient of x square, and product of zeros is given by constant term divided by coefficient of x square. Now let us try to generalize it. Suppose p of x is any polynomial and it is given by ax square plus bx plus c, and alpha and beta are its two zeros. And we have studied that the maximum number of zeros a polynomial can have is equal to its degree, and the degree of this polynomial is 2, so maximum p of x can have only two zeros. So if alpha and beta are its two zeros, then we know x minus alpha and x minus beta will be its factors by the factor theorem which we learnt in class 9th. So x minus alpha and x minus beta are the factors of p of x, the polynomial, the quadratic polynomial in fact. So its degree is 2, and if I multiply x minus alpha and x minus beta, its degree will also be 2. So we can say that ax square plus bx plus c will be of the form x minus alpha times x minus beta, its two zeros, and for the coefficient of x square we may have to multiply by some constant, that is k. Even if we multiply by k to the right hand side, its zeros will remain same, and this k should be non-zero real constant. K is non-zero real constant. And we know why it can't be 0. If it is 0, then the right hand side whole will become 0. So ax square plus bx plus c will be of the form k times x minus alpha times x minus beta, where k is a non-zero real constant. So if we try to simplify the right hand side, so we can say k times, if we multiply by x, so it will be x square minus x beta, and then if we multiply by alpha to the right bracket, so it will be minus alpha x, and minus times minus will be plus and alpha times beta. So after simplification, this will be there, and if I open the bracket and take x common, so I will be getting kx square, and if taking k common, so it will be negative kx, and I have taken negative common, so remaining will be alpha plus beta plus k times alpha beta, and this is equal to the polynomial ax square plus bx plus c. Now if we try to compare the coefficients of the same degree variable, so the coefficients of x square, by comparing on both the sides, we get k is equal to a, and the coefficient of x we will be getting b is equal to negative k times alpha plus beta, and comparing the constant terms we will be getting c is equal to k alpha beta. So from here, if I divide the first two things, means negative k times alpha plus beta divided by k, I will be getting b by a. So from here, k will be cancelled out, and I will be getting alpha plus beta is equal to, we can multiply by negative sign on both the sides, so we will be getting negative b by a. Similarly, if I divide k alpha beta by k, I will be getting k alpha beta is c and k is a. So k will cancel out, so we will be getting alpha into beta is equal to c by a. So from here, we can say that if there is a quadratic equation ax square plus bx plus c, and its roots are alpha and beta, so we can say alpha plus beta. What is alpha plus beta? Alpha and beta are the roots, and we are adding them. So we can say this is sum of roots is given by minus b by a, and alpha into beta, that is product of the roots. Product of roots will be given by c by a, that is constant term divided by the coefficient of x square. So I hope this would be clear. In the above example, we saw that if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, so it can be written as kx square minus kx alpha plus beta plus k times alpha beta. If I mark this equation as 1, then we can write this as, so it was ax square plus bx plus c, and it was given as kx square minus kx alpha plus beta plus k times alpha beta. So this was the equation which we had got in the earlier problem. Now if I take k common, so I can write it x square minus alpha plus beta times x plus alpha beta. So we can write this k times x square minus alpha plus beta is sum of the roots. Sum of roots times x plus alpha into beta is product of roots. So if I know the two roots of ax square plus bx plus c, I can write this polynomial quadratic equation by k is times x square minus sum of the roots into x plus product of the roots, there will be infinite number of polynomials which will be having the roots alpha and beta. And to find this particular quadratic equation, there will be some condition given in the question, and by using that we need to find out the value of k. So let us try a problem based on this concept. So the question is, find a quadratic polynomial, the sum and product of whose roots are -4 and 3. So remember, students, here the sum and product of the zeros are given -4 and 3. So we have to be very cautious. Many times we assume that -4 and 3 are the roots of the equation, and then we find out their sum and the product, and that leads to our wrong result. So I have always said that if we understand the question correctly, then our half the question is solved at that place only. So try to read the question properly, and first of all try to comprehend that what is given. Don't rush to solve the problem. In the earlier question, we saw that if we know the sum and product of the roots of a quadratic equation, we can write that quadratic equation. Let's the quadratic polynomial be p of x. So we know p of x, we can write this as k times x square minus sum of roots times x plus product of roots. And the bracket is closed. So here k times x square minus sum of the roots. It's already given, sum of the roots is -4. So remember students, here we have to be careful because negative sign is already there and the sum of the roots is also negative. So we have to be careful. I have to write -4 in the bracket, not only 4. Don't assume that negative is already there and the sum is -4, so it will become -4x. No. The sum of the roots is -4, so in place of the sum of the roots which is given in the bracket, we have to write -4 plus product of the roots, so given 3. So we can write this as k x square, negative times negative is plus 4x plus 3. So this is one of the polynomial having the sum of the roots as -4 and product of the roots as 3. And there is no other condition given, so we will not be able to find out the value of k. So we can assume, to just simplify our answer, we can assume if k is equal to 1, then the polynomial p of x will be x square plus 4x plus 3. So this will be the answer, a polynomial having their sum of the roots as -4 and product of the roots as 3. Now students, we learnt about the quadratic equation and the relationship between their roots and the coefficients. Now, if I ask a question, is there any relationship between the roots and the coefficients of a cubic polynomial? To understand that, let us take an example. So let us take a cubic polynomial p of x. Let me choose another color. So let us take a cubic polynomial p of x is equal to 2x cube minus 5x square minus 14x plus 8. So this is a cubic polynomial and we will try to find out, is there any relationship between their coefficients and their roots. So first of all, we will try to find out the roots of this cubic polynomial, and then using those roots we will try to understand what is the relationship between their roots and the coefficients. So if I try to find out the value of this polynomial at 4, So we will get 2 into 4 cube minus 5 into 4 square minus 14 into 4 plus 8. So 4 cube is 64, 64 into 2 is 128, minus 4 square is 16, 16 into 5 is 80, minus 14 into 4 is minus 56 plus 8. So we can see 128 plus 8 is 136 and 80 plus 56 is also 136. So this is 0. Now the value of this polynomial at x is equal to 4 is 0. So we can say 4 is one of the roots of p of x. So students, you might have wondered that why I tried 4 only. Maybe I would be aware about this value. So I was aware about this value, but you can also guess that whatever be the roots of this polynomial will always be of the form p by q, where p will be a factor of the constant term and q will be a factor of the coefficient of the highest degree. So in this way, you can try to find out you can make a guess about the roots of the polynomials. So 4 is one of the roots of this polynomial, and because here our main focus is to try to find out the relationship between the coefficients and the roots of the polynomial. So we will not focus on how to find out the roots. Similarly, you can find out negative 2 and 1 by 2 are other two factors of p of x. So p of x was a third degree cubic polynomial and we have got three roots, 4, negative 2 and 1 by 2. Now we can think of, is there any relationship like the quadratic polynomial? So in quadratic polynomial, we found out the sum of the roots and tried to find out what is the relationship with their coefficients, and we tried to find out the product of the roots, and then we found out the relationship between the coefficients and the roots. So similarly, let us try to find out the sum of the roots here. So if I try to find out the sum of the roots, so it will be 4 plus minus 2 plus 1 by 2. So 4 minus 2 is 2, 2 plus 1 by 2 is 5 by 2. 2 plus 1 by 2, 2.5, 2.5 is 5 by 2. So we can see here 5 by 2 can be written as negative of negative 5 over 2, and negative 5 was the coefficient of x square and 2 is the coefficient of x cube. So we can write here it is negative times coefficient of x square divided by coefficient of x cube. So sum of the roots in a cubic polynomial is given by negative times coefficient of x square divided by coefficient of x cube. Now, in the case of a quadratic equation, we had only 2 roots, but in case of a cubic equation, we have 3 roots. So we can try to find out sum of product of roots taking 2 at a time. Taking 2 at a time means alpha, beta and gamma are suppose 3 roots of this polynomial. So taking 2 at a time, alpha into beta, beta into gamma, gamma into alpha. So here the roots were 4, negative 2 and 1 by 2. So we can try to find out 4 times negative 2 plus negative 2 times 1 by 2 plus 1 by 2 times 4. So there are 3 things and we have to multiply them 2 at a time. So we can group 2 things out of 3 things in 3 ways. So 4 and 2, negative 2 and 1 by 2 and 1 by 2 and 4. So if I find out 4 into negative 2 is negative 8 and this I can cancel out. So negative 1 plus 2. So which can be written as negative 9 plus 2, so negative 7. Now if I try to see the coefficients of the polynomial, so the coefficient of x is negative 14 and coefficient of x cube is 2. So negative 7, I can write it as negative 14 divided by 2, and negative 14 was the coefficient of x. So I can write this coefficient of x divided by coefficient of x cube. So students, we saw that sum of the product of roots taking 2 at a time is given by coefficient of x divided by coefficient of x cube, and remember this is true for a cubic equation. Now we had 3 roots, we have found out their sum taking 1 at a time, their sum taking 2 at a time. Now we can multiply all the 3 roots together. So we can write product of the roots will be given by root was 4 times negative 2 times 1 by 2. So we can cancel 2. So it will be negative 4, and if I check the polynomial, so it will be 8 divided by 2 is 4 and it is negative, so I can write it negative times 8 by 2. So I can write it negative times 8 was the constant term divided by coefficient of x cube. So in this way, students, we saw the relationship between the roots of a cubic polynomial and their coefficients. So we saw that sum of the roots will be given by negative times coefficient of x square over coefficient of x cube. Sum of product of roots taking 2 at a time will be given by coefficient of x divided by coefficient of x cube, and product of the roots will be given by negative times constant term divided by coefficient of x cube. So in this way, we can find out the relationship between the coefficient of a cubic polynomial and their roots. So similarly, as we wrote in case of a quadratic equation, if I know the 3 roots, I can write the polynomial directly. So if we try to generalize it, so if there are 3 roots alpha, beta and gamma of a cubic polynomial, so let p of x be a cubic polynomial and it is given by ax cube plus bx square plus cx plus d is a cubic polynomial and its 3 roots are alpha, beta and gamma. So we can write it ax cube plus bx square plus cx plus d will be equal to, as alpha, beta and gamma are their roots, so I can write x minus alpha, x minus beta and x minus gamma will be their factors. So a cubic equation can have maximum 3 factors only, and just to equate the coefficients of same degree on both the sides, we will multiply by some constant k. Let us simplify the first 2 brackets. So I will be getting x into x, x square minus beta x and negative alpha multiplied. So negative alpha x, negative into negative is positive alpha beta. So this is the product of the first 2 brackets, and x minus gamma is already there. So we can now multiply x minus gamma to this. So I will be getting x cube minus beta x square minus alpha x square plus alpha beta x, and we can multiply negative gamma. So I will be getting negative y x square gamma x square negative gamma x square plus beta gamma plus beta gamma x plus alpha gamma x minus alpha, beta, gamma. Now if I bring same degree terms together, so I will be getting x cube minus x square. I will be getting alpha plus beta plus gamma. I will be taking from everywhere, and then x common, so coefficients of x, alpha beta plus beta gamma plus gamma alpha minus alpha beta gamma. So this is the simplified version of k times x minus alpha, x minus beta, x minus gamma, and this is equal to ax cube plus bx square plus cx plus d. Now if I equate the coefficients of the same degree on both the sides, so we will be getting a is equal to k, b is equal to negative k times alpha plus beta plus gamma, c is equal to k times alpha beta plus beta gamma plus gamma alpha, and d is equal to negative alpha beta gamma, and there will be k also, negative k times alpha beta gamma. Now if I want to find out, or if I divide minus k alpha plus beta plus gamma divided by k, so it will be b by a. So from here I can say alpha plus beta plus gamma will be equal to negative b by a. Similarly, if I divide k alpha beta plus beta gamma plus gamma alpha by k, so I will be getting c by a, and this will cancel out. So alpha beta plus beta gamma plus gamma alpha is equal to c by a. Similarly, minus k times alpha beta gamma by k, we will be getting d by a. So k will cancel out. So from here I can say alpha beta gamma is equal to minus d by a. So sum of the roots taking one at a time is given by negative times b by a, where ax cube plus bx square plus cx plus d is the given cubic polynomial. Sum of the product of the roots taking 2 at a time is given by c by a, where c is the coefficient of x and a is the coefficient of x cube, and product of the roots taking all the roots at a time is negative d by a, where d is the constant term and a is the coefficient of x cube. And students, here only we can see k times x cube minus x square. This is sum of the roots taking one at a time, so we can denote it by s1, where s is sum and 1 denotes taking one root at a time, plus x, sum of the product of the roots taking 2 at a time, so we can write s2, where s denotes sum and 2 denotes taking 2 at a time, negative product of the roots is p. So students, we can write the cubic polynomial if I know sum of the roots taking 1 at a time, sum of the product of the roots taking 2 at a time, and the product of all the 3 roots at a time. So if I know that, I can write it x cube minus x square into sum of the roots plus x into sum of the product of the roots taking 2 at a time minus times product of the roots. So if you worry about the signs, you can just see it starts with negative and it changes negative, positive, negative. So it goes alternate. So in this way, we can write a cubic polynomial if I know all the 3 roots. So students, this third degree polynomial is not in our NCERT syllabus. This was previous there in the NCERT syllabus, but now they have rationalized the syllabus and they have removed this part. So you don't need to worry about that. I just taught you so that you should know the things. Whether it is checked in your exam or not, it doesn't matter. But it creates an interest in your subject and you know the reasons behind what is happening. So now we have studied all the concepts required for solving exercise 2.2. So let us start solving questions from exercise 2.2. So let us try the first question. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So we have to first of all find out the zeros of the quadratic polynomials, and then we have to verify the relationship between the zeros and the coefficients. So let us try the first part of this. So question number 1, part 1. So the polynomial given is x square minus 2x minus 8. So x square minus 2x minus 8, and we have to find out the zero of this polynomial. So to find out the zero of this polynomial, I have to equate it to 0. So x square minus 2x minus 8 is equal to 0. Now to simplify it, or to break this polynomial into its factors, we will use splitting the middle term. So in splitting the middle term, what we do, here the coefficient of x square is 1. So the coefficient of x, that is negative 2, and the product of the roots will be negative 8. So I have to find out two numbers whose sum is minus 2, that is the coefficient of x, and whose product is negative 8, that is the constant. So the factors of 8 is 4 and 2, whose difference will be 2. So if I want the sum as negative 2, so I can write it negative 4 plus 2, and I know negative 4 into 2 will also be negative 8. So these two numbers satisfy our criteria. So we can use these two numbers to factorize this quadratic polynomial. So it will be x square minus 2x can be written as negative 4x plus 2x minus 8 is equal to 0. So we wrote negative 2x as negative 4x plus 2x, which were the numbers which we found the sum as negative 2. So now we can take x common in these two, so it will be x minus 4, and 2 is common in these two, so we can take 2 common, so x minus 4 will be left. Now in these two terms again x minus 4 is common, so x minus 4, and after taking x minus 4 common, x will be left with the first term and plus 2 is left with the second term. Now x minus 4 and x plus 2 are two numbers and their product is 0, and remember students, they are real numbers. So product of two real numbers can be 0 only if at least one of them is 0. So from this we can infer that either x minus 4 is equal to 0 or x plus 2 is equal to 0. So from here I can say x is equal to 4 or x is equal to negative 2. So the two roots of this quadratic polynomial x square minus 2x minus 8 are 4 and negative 2. Now we have to verify the relationship. So to verify the relationship, between zeros and the coefficients. So we know let alpha is equal to 4 and beta is equal to negative 2. So sum of the roots alpha plus beta will be 4 plus minus 2 is equal to 2, and minus b by a, if I compare, let us compare, our equation was x square minus 2x minus 8, and let us compare it with ax square plus bx plus c. So we know a is equal to 1, b is equal to negative 2, and c is equal to negative 8. So from here, if I want to find out negative b by a, so I can write it negative times b is negative 2 by a, that is 1, so 2. So from here, from 1 and 2, so we can write from 1 and 2, we can say alpha plus beta is equal to negative b by a, and this is what we needed to verify. Now similarly, we can check for alpha into beta, that is product of the roots. So we will get 4 times negative 2, that is negative 8. And if we find out c by a, so c by a, c is negative 8 and a is 1. So negative 8 by 1 will again be negative 8. So from 3 and 4, we can say from 3 and 4, we can say product of the roots, that is alpha into beta, is equal to c by a. So from these two statements, we verified that alpha plus beta is equal to negative b by a and alpha into beta is equal to c by a, where b is the coefficient of x, a is the coefficient of x square, c is constant term. So in this way, we can solve such type of questions. So to find out the roots, what we did, we first solved the factorized the quadratic equation by splitting the middle term. We factorized the quadratic equation by splitting the middle term, and then we found out its zeros, and then we found out the sum of the zeros and product of the zeros, and verified that with negative b by a and c by a respectively. So this was an easy question just to see the application of the concepts which we learned. Now, let us try one more problem from the exercise 2.2. Let us try part 3 of the question number 1, that is 6x square minus 3 minus 7x. So the polynomial given here is 6x square minus 3 minus 7x. So let us try question 1 part 3. It is 6x, polynomial is 6x square minus 3 minus 7x. So this is the polynomial given, and students, we can see the polynomial is not in standard form. Not in standard form means what? The standard form of any polynomial is written in the form of decreasing order of the degree of the terms. So first of all, let's write it in the standard form. So it will be 6x square minus 7x minus 3. So this is the standard form of this polynomial. So students, first of all, we have to factorize this quadratic polynomial. Now to factorize this quadratic polynomial, what we do? We find out the product of the coefficient of x square and the constant term, that is negative 18, and the coefficient of x is negative 7. So we have to find out two numbers whose sum is negative 7 and product is negative 18. So because product is negative 18, so I know one of the numbers will be negative and other will be positive, then only its product will be negative. And we want their sum to be negative 7. It means the negative root is greater than the positive root. Magnitude of the negative root is greater than the magnitude of the positive root. So I know 9 and 2 are two factors of 18. So I can write it negative 9 into 2 and negative 9 plus 2. So these numbers negative 9 and 2 satisfy our criteria. So now we can break negative 7x as negative 9x plus 2x. So we can write it 6x square negative 9x plus 2x minus 3. Now what is common in between these two? So in between these two terms, we can see 3 is common between 6 and 9. So I can write 3, and x is common between x square and x. So we took 3x common. So what is left? 2x minus 3. And we can take plus 1 common in between these two, because 2 and 3 are co-prime and there is no x with the constant term. So only 1 is common. So I can write 2x minus 3. Now again 2x minus 3 is common in between these two. So we can write 2x minus 3. So what is left? 3x plus 1 is equal to 0. So we factorized p of x as 2x minus 3 and 3x plus 1, and their product is equal to 0. So we can say either 2x minus 3 is equal to 0 or 3x plus 1 is equal to 0. Now 2x minus 3 is equal to 0 means 2x is equal to 3, or 3x plus 1 is equal to 0 means 3x is equal to negative 1. Now 2 is multiplied by x, 3 is multiplied by x. So if I shift to the other side, so I can say x is equal to 3 by 2 or x is equal to negative 1 by 3. So we got the two roots, 3 by 2 and minus 1 by 3. Let us assume these roots, let alpha is equal to 3 by 2, beta is equal to minus 1 by 3 are two roots. So we can find out alpha plus beta, their sum 3 by 2 plus minus 1 by 3. So plus into minus is minus, so I can write it 3 by 2 minus 1 by 3. Now 2 and 3 are co-prime, so we can multiply by 3 to the first rational number and by 2 to the second rational number in the numerator and denominator, and we can equate the denominator. So multiplying by 3 to the first rational number, we will be getting 9 by 6 minus multiplying by 2, so I will be getting negative 2 by 6. Now the denominators are equal, so we can subtract the numerators. 9 minus 2 is 7 by 6. Now if we compare 7 by 6 with the polynomial, so polynomial is 6x square minus 7x minus 3, so I can write 7 by 6 as negative of negative 7 by 6, and that is negative b by a, where b is the coefficient of x and a is the coefficient of x square. Similarly, alpha into beta is equal to 3 by 2 into minus 1 by 3. We can cancel 3, so I will be getting minus 1 by 2, and if we compare it with our polynomial, that is quadratic equation, so it can be written as negative 3 by 6. So negative 3 by 6, which is negative times, sorry, negative 3 was already constant term, so this can be written as c by a. We can check, negative 3 is already the constant term, so I can replace negative 3 by c by a. And remember students, a, b, c are the coefficients of x square, x and the constant term in ax square plus bx plus c that we will be taking in every problem. That will be the standard polynomial through which we will be comparing the coefficients of the other polynomials to find out the value of a, b and c, so that we don't need to write always the coefficient of x square, coefficient of x and the constant term. That will save our time. So again in this quadratic equation we saw that the product of sum of the roots is negative b by a and the product of the roots is c by a. So we verified the relationship between the sum of the roots and product of the roots and the coefficient of the polynomial. So in this polynomial, in this question, the quadratic equation was not in the standard form. So first of all, we wrote that in the standard form so that it will be easier for us. So students, I took this question just to make a point that whenever the polynomial is not given in the standard form, first of all, write that in the standard form. Let us take one more example, part 5, t square minus 15. So this is the polynomial given and we have to find out its zeros. So to find out the zeros, let's equate it to 0. Now t square minus 15 is equal to 0. There is no t in this. So, and the product of the roots should be negative 15. And sum of the roots should be 0. So I can write this as t square minus 15 can be written as root 15 square. Now this polynomial is in the form of a square minus b square is equal to 0, and we know a square minus b square can be written as a plus b and a minus b. So we can write it t plus root 15 times t minus root 15 is equal to 0. Again, product of two numbers is 0, so I can say t plus root 15 is equal to 0 or t minus root 15 is equal to 0. So from here I can say t is equal to minus root 15 or t is equal to root 15. So we got the two roots as negative root 15 and root 15. Now similarly we can verify the relationship between the roots and the coefficients. So for that we can take, let alpha is equal to minus root 15 and beta is equal to root 15, and remember students, we will be taking ax square plus bx plus c as our standard quadratic equation, and the sum of the roots is given by negative b by a and the product of the roots is given by c by a. So students, our polynomial is t square minus 15. Let us compare it with at square plus bt plus c to find out the values of a, b and c, so that we can verify the relationship between the coefficients and the roots. So comparing the coefficients of the like terms, I can say a will be 1, b will be 0 as there is no t on the left hand side, and c constant term will be negative 15. So now alpha plus beta, that is sum of the roots, is negative root 15 plus root 15 is equal to 0, and that can be written as negative b by a. Because b is 0, so negative b by a will also be 0. Similarly, product of the roots alpha into beta is negative root 15 times root 15 will be equal to negative 15, and we can see negative 15 can be written as c by a. So we verified that the sum of the roots is negative b by a and product of the roots is c by a. So our question is done. So in this case there was no term containing t, only t square and the constant term was there, and found out its roots and then verified the relationship between sum of the roots and the coefficients of the quadratic polynomial. So students, we have tried some parts of the question number 1. Rest of them you can solve by yourself just to check your understanding. Now let us try some questions from the part 2, that is question number 2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So remember again, the sum and the product of the roots is already given. So we don't have to add and multiply them. So we know students, when the sum and product of the roots is given, we can write the polynomial as k x square minus sum of the roots into x plus product of the roots, where s is sum of the roots and p is product of the roots. So using this concept, I can find out the quadratic polynomial whose sum and product is given. So let us try question number 2, part 1. 1 by 4 is the sum of the roots and minus 1 is the product of the roots. So we can write the polynomial as k x square minus 1 by 4x plus product of the roots is minus 1. So we can write k, and we can multiply and divide by 4 in the whole equation. So here I will be dividing by 4 and I will be multiplying by 4 inside the bracket. So it will be 4x square, and here negative 4 times 1 by 4x plus 4 times minus 1. So we divided by 4 outside the bracket and multiplied by 4 inside the bracket so that there is no change in the value. So I can write that as k by 4, it will be 4x square minus x minus 4. Now k was a constant, and when we will divide it by 4, then again it will be a constant. So I can replace that as k prime is equal to 4x square minus x minus 4, where k prime is equal to k by 4. So k prime is any constant, and if it is 1, then the quadratic equation with sum of the roots as 1 by 4 and product of the roots as minus 1 will be 4x square minus x minus 4. So this is one of the quadratic equation whose sum of the roots will be 1 by 4 and product of the roots will be minus 1. Now let us try question number 2 part 3. So question number 2 part 3. So first we did, let's part 3. So sum of the roots is 0 and product of the roots is root 5. So we can see here s is equal to 0 and product of the roots is root 5. So let me check once again. Yes. So we can write the quadratic equation as k x square minus sum of the roots plus product of the roots. So that will be k x square minus 0 times x plus product of the roots is root 5. So from here we can get x square plus root 5. So this is a quadratic polynomial whose sum of the roots is 0 and product of the roots is root 5. And if k is equal to 1, x square plus root 5 will be one of the infinite polynomials whose sum of the roots is 0 and product of the roots is root 5. In many books, students, k will not be there, but I am writing k just to make you aware that there will be infinite number of polynomials whose sum of roots and product of the roots will be given will be same as given in this question. Just remember that k cannot be 0. It is a non-zero integer, or it can be any fraction, or it is non-zero real number. To be more safe, we can say k is a non-zero real number. So now let us try question number 2 part 4. So part 4, sum of the roots is 1, product of the roots is also 1. So I can say sum is 1 and product is also 1. So we can write the polynomial as k x square minus sum of the roots into x plus product of the roots. So that will be k x square minus 1 times x plus 1. So that will be k x square minus x plus 1. So again, students, x square minus x plus 1 times k is a polynomial whose sum of roots is 1, product of the roots is also 1, and again k signifies that there will be infinite number of polynomials whose polynomials, or to be more accurate, quadratic equations, as this was the question about a quadratic equation. So there will be infinite number of quadratic equations whose sum is of the roots is 1 and product of the roots is also 1. So k is a non-zero integer here. So students, I hope you have understood the concepts and the solutions as well. If not, please go through the video once more. To check your understanding, you can solve questions from the NCERT Exemplar based on these concepts. If you like the video, don't forget to hit the subscribe button. In the next lecture, we will meet with the further concepts and exercise 2.3 of the NCERT book. Till then, take care and keep on practicing.